This is part 2 of the mid-year exam review for chemistry. Which statement best describes what happens when atoms absorb energy? What you want to keep in mind here is something called quantum theory and the Bohr model of the atom. And Bohr's model tried to explain why elements gave off different colors of light when you heated them up. And the theory that he came up with was that as electrons orbited the nucleus in different levels, they could absorb energy from the outside and then use that energy to jump to a higher energy level. And then when they came back down, they released that energy in the form of visible light. So the correct answer here is that electrons use energy to jump to higher energy levels. Answer C. Which of the following elements would be the most similar to phosphorus? Phosphorus is in group 15. So in order to find elements that would be similar, you would look at other elements in the same group or column of the periodic table. In this case, the choice is nitrogen. It's also in group 15, and therefore it should have similar properties to phosphorus. Which of the atoms in the diagram represent an ion with a charge of +1? In order to solve this, you have to keep in mind that the charge of an atom, whether it's positive, negative, or neutral, has to do with the balance between the number of protons and the number of electrons. Protons are positive, electrons are negative, so depending on the comparison between those two, you can end up with positive, neutral, or negative. In this case, we're looking for a charge of +1, which means there's one less electron than there are protons, so we need to look at the numbers. In A, there's 1, 2, 3 protons, positive symbols in the nucleus, and 1, 2, 3, 4. So 3 protons and 4 electrons means that the actual overall charge would be negative, because there's more negative than positive. In B, we have 4 protons, positive, and 1, 2, 3 electrons, which are negative. So that would be a balance of +1. So that tells us that the answer here is B. And then if you look at the other two, choice C is the same essentially as choice A in terms of the protons and electrons, and choice D has an equal number of positive and negative, which means it would be neutral overall. Which causes an object to have a negative charge? Well, as we discussed in the last slide, the charge has to do with the balance between protons and electrons. What you have to remember for this question is that the number of protons in an atom does not change during any of these changes from neutral to positive or negative. The thing that changes is the electrons. And in order to have a negative charge, that means you need extra electrons. So the choice would be D, electrons are added. Remember, protons are never added or removed during a chemical reaction. Which of these is the correct formula for magnesium sulfate? So we need to find a couple of things here. We need to figure out the charge of the ions involved. Magnesium is in group 2, and therefore we'll have a charge of +2 when it forms an ion. Now sulfate, you have to be careful, sulfate, that ATE ending, indicates that this is a polyatomic ion. And sulfate, if you look it up on your chart, is an ion with the formula of SO4, and it has a charge of -2. Anytime the positive and negative charges of the ions are equal, then it's simply a 1-to-1 ratio. And in this case, MgSO4 would be the formula that most correctly identifies that. The one below, MgSO4 with the SO4 in parentheses, is only technically incorrect because you don't need the parentheses. So that's the difference there. Uranium-238 undergoes alpha decay and produces an atom of thorium-234, as shown below. Here's the nuclear equation. And which of the isotopes would be produced by radon-222 when it undergoes alpha decay? So what you want to do here is sort of model using the equation above. So we have radon, which is 222, and you would look up its atomic number, which is 86. And since they're both alpha decay, we have this alpha particle, which is part of the process of any alpha decay. What remains is an isotope with a mass of 218, because the numbers on the top have to equal the same total on both sides. So 222 is the same as 4 plus 218, and the atomic number would be 84. And if you look that up on the periodic table, you'd see that element number 84 is polonium. So that's polonium-218 is the name of that isotope. Which of the following was formed when two non-metal atoms share electrons? So the key here is really sharing electrons, but also anytime you have two non-metal atoms bonding, they're going to form the same type of bond. And it involves sharing electrons, and the name for that is covalent bonding. Okay? Sharing of electrons results in covalent bonding. An ionic bond is formed when atoms exchange electrons. Which of the following is true of nuclear reactions? Well, nuclear reactions are different from chemical reactions in a lot of ways. They release massive amounts of energy compared to chemical reactions. They are typically not affected by things like temperature and pressure. But the key here, as far as these choices are concerned, is that unlike a chemical reaction, a nuclear reaction produces entirely different elements. So in a chemical reaction, you can have different compounds that are formed, or a compound that breaks down into its component elements, but the elements themselves do not change during a chemical reaction. In a nuclear reaction, though, you can actually produce new elements. Thorium-232 has a half-life of 5,000 years. How much of a 100-gram sample will remain after 15,000 years? So to figure this out, you have to remember that half-life means during each length of time that's designated as a half-life, in this case, during each cycle of 5,000 years, half of what you have decays. So if we're starting at 0, so no time, today, for example, with 100 grams of this isotope, well, after one half-life of 5,000 years, we would have 50 grams left. At 10,000 years, which would be the next half-life cycle, we would have 25 grams, half of the 50 that we had at 5,000 years. So then we add on another 5,000 years, or one more half-life, we get to 15,000, which is where we're trying to get to. We cut the 25 in half, and we're left with 12.5 grams. So that's answer B. What is the correct formula for the ionic compound formed by the reaction of potassium and sulfur? So just like when we had earlier, the key here is first identify your ions. So potassium, sulfur. Potassium is in group 1, so it'll have a charge of +1. Sulfur is in group 16, so it'll have a charge of -2 when it forms an ion. So what that means is it takes 2 potassiums for every sulfur. And so the 2 potassiums with a charge of +1 each gives you a total of +2. The sulfur gives you a charge of -2. So when we write that as a formula, we would write it as K2 to show that there's 2 of them, and then S to show that there's one S. So that's choice C. Which of the following elements is most likely to have a larger radius than calcium? So you have to remember that the radius gets smaller from left to right. So as you go across each row, the radius gets smaller, and it gets bigger as you go down. So if you're looking for one that's bigger than calcium, you'd want to find an element that is either to the left of calcium or below. And so all of these elements are either to the right, which makes them smaller. Scandium and argon are to the right. Magnesium is above, so that makes it smaller. So the only one that we can say for sure would have a bigger radius is strontium, because it's below calcium on the periodic table. Which of these is part of the alkaline earth metal family and found in period 4? There are two parts to this. One is the alkaline earth metal family. That is group number 2 on the periodic table. So the second column, and it's found in period 4, so that is the 4th row. So the element that's in group 2, period 4, is calcium. Just be careful with that, because if you're not careful in counting the rows, you might think it was strontium. If you chose strontium, it's because you started counting with beryllium, which is actually in the 2nd row. The 1st row is just hydrogen and helium, so it's very easy to miss that, but just be careful when you're counting the rows that you know exactly what row you're looking at. Which best describes the difference between an element and a compound? Well, the first one is actually kind of the reverse. Elements are not made up of more than one type of atom. They're all the same, and compounds are all made of different elements. All right? Elements cannot be separated physically, and actually neither can compounds. And elements are always the same, but compounds always have the same composition. That's what makes them a compound. So the choice that we haven't eliminated, and it's the correct one, is that elements are all the same type of atom, and compounds are made of 2 or more elements. So element is the simplest type of matter, and then a compound is made of groups of matter. What is the correct formula for calcium phosphide? All right, so we have calcium, and we have phosphide, which is the name we use for phosphorus when it's in a compound. Since it's a metal and nonmetal, it's going to be an ionic compound. Calcium is in group 2, has a charge of +2. Phosphorus is in group 15, so it's going to have a charge of -3. In order for these to cancel out, we have to find a number that both of these will go into, because they don't go together directly, they're not balanced, and you can't just have 2 calciums and a phosphorus because they don't match up. So the smallest number that they both go into would be 6. And in order to get a total plus charge of 6, positive charge of 6, I would need 3 calciums. All right, 3 calciums times +2 each gives you a charge of 6. And then it would take 2 phosphorus, or phosphide ions, 2 times 3 gives you 6. So what we really did here is we took the charge of the positive ion and we used it as the subscript of the negative ion in the formula, and we used the charge from the negative ion and used it as the subscript for the positive. So if you swap those two numbers, you will always get a neutral compound. So the choice here is Ca3P2 or choice B. Okay, what type of equation does this represent? Carbon becoming nitrogen and releasing a particle. So this is a nuclear reaction, and in the case, what we're looking for here is what is the particle that gets released, because that really defines the type of decay that we're working with. That little particle with no mass and a negative charge, which is essentially an electron, is called a beta particle, which means it's beta decay. Alpha decay would have that 4,2 alpha, or sometimes written as 4,2 He. That would indicate alpha decay, but in this case we have a beta particle, which means beta decay. And which of these describes correctly what a beta particle is in terms of its charge and mass? Well, as we just saw, it's a negative charge, so we can cross out the two that say positive. So now we have to look at the mass part of it. Well, beta particles have essentially no mass. They're an electron, very, very small in terms of their mass. Alpha particles are relatively large in terms of mass. So what we're looking for is a negative charge and less mass compared to alpha particles. So that's choice B. So we have some boxes representing different elements with the different colored dots, and it says that if they're touching, they're considered to be bonded. So which of these boxes contains only a compound? Remember, a compound has to be made up of two different elements. Well, box A has a molecule, but each of those atoms, they're all the same, so that's actually an element. Box B has a compound here, right? That's two different types of elements bonded together, but it also has this other solo element or atom, so that makes that a mixture, not a compound. And just like in choice A, choice C is made up of all the same type of atom, so that's an element. So the only choice that's left is D, which has molecules made of two different elements bonded together. All right, which of these is most likely to form an ionic compound? You have to remember, ionic compounds are always metal plus nonmetal. Okay, so you can have an element from the left-hand side of the periodic table and one from the right-hand side of the periodic table. Metal and nonmetal makes an ionic compound. Metals don't typically bond to each other, and nonmetals can bond to each other, but when they do, they form covalent compounds. So the ones here, so potassium and calcium are both metals, carbon and oxygen, both nonmetals, neon and fluorine are both nonmetals, and neon's a noble gas anyway. So the only one that's a metal and a nonmetal, which would form an ionic compound, is calcium and chlorine. Which of these pictures contains only molecules? So this is different from the last question, which said compound. So it's molecules, which could be either elements or compounds. So choice B has these lone atoms here floating around, so that's not going to be correct. The same can be said for choice D. Choice A has a compound here made up of two different elements. It also has an element, but those elements, the atoms of those elements are bonded together, which does create a molecule. So these are two different types of molecules, but the question just said contains molecules. So A would be correct. C would also be correct because it contains molecules of all the same compound. But since the question said molecules, not compound, the choice is A and C, which is answer choice D. How many different elements are present in the compound ammonium phosphate with the formula of NH4PO4? You have to remember in this case that when you look at a chemical formula, each capital letter in a formula represents a different element. So in this case, there's 4 letters. They're all capital letters, so that means that this contains 4 different elements. Nitrogen, hydrogen, phosphorus, oxygen. Every capital letter is an element. What type of bond is formed when 2 atoms exchange valence electrons? Okay, we had a similar question to this before. Talked about sharing electrons. When electrons are exchanged or actually move from one atom to another, that creates positive and negative particles, and those are attracted to each other in what's called an ionic bond. The previous question was about covalent bonding, which is sharing electrons. This is exchanging electrons, which is ionic bonding. What is the correct name for this compound? Ca3PO4 with the PO4 in brackets and 2. Well, Ca3 is calcium. So whenever you have just an element as your first portion of a compound, you're just going to use the name of that element. So that doesn't help us eliminate any choices, but it is just something to keep in mind. Now the part that's in parentheses here, the PO4, the fact that there's 2 capital letters there tells us that that's what's called a polyatomic ion. And the name of that polyatomic ion, if you look it up on your chart, is phosphate. whenever you have a polyatomic ion, you do not change the ending or the name in any way. So with elements, we would change, for example, chlorine to chloride. But with polyatomic ions like phosphate, we don't mess with the name. So it's not phosphorus oxide, so we can eliminate that, and it's not phosphide. Phosphide is actually what we call phosphorus by itself when it's in an ionic compound. So now I have to choose between A and C, and the difference between A and C is that Roman numeral in the middle. Calcium is in group 2, and it always forms a +2 ion. And for elements that always form a single oxidation state or a single charge, we don't need a Roman numeral. Okay, so we can cross that out. The last choice here is A. What is the correct formula for the compound magnesium hydroxide, also known as milk of magnesia? So magnesium, that's Mg, that's an element. Hydroxide, if you look it up on the periodic table, you'll find that it's not on the periodic table because hydroxide is the name of a polyatomic ion. That polyatomic ion is made up of oxygen and hydrogen, OH. So if you look up the charges, magnesium is in group 2, that's a +2. Hydroxide, again, polyatomic ion, you have to look it up. If you look at the chart, you'll see that it has a charge of -1. And so that means it's going to take 2 hydroxides to give us a charge of -2 to balance out the +2. So we would write that as Mg, because we only need one of those. Since we need multiple hydroxides, we put OH in brackets to keep that unit together. And then we needed 2, so we put a little 2 on the outside. Again, what we did is we switched the numbers. The key here, though, is we need these parentheses because this is a polyatomic ion. So the answer here is MgOH2. Disulfur tetrachloride, what is the correct formula? Okay, so this is, got the prefixes here, so disulfur and tetrachloride. So you're going to have to go back and look at those prefixes. Well, the prefix di, di, means 2, so 2 sulfurs, and the tetra prefix means 4. So we're looking for something with 2 sulfur and 4 chlorine. That would be S2Cl4, choice C. All right, another naming with a typo. Which of the following is the correct name for the compound F2S3? All right, so iron is Fe, so they all start with iron, so that doesn't help. And then sulfur is S, so it would become sulfide. So they all have iron and sulfide. Now the question is, what are we going to do about these Roman numerals? Well, sulfur is in group 16. It has a charge of -2. Iron is a transition metal from the middle of the periodic table, and it's one of these elements that can have multiple oxidation states or multiple charges. So we're going to need a Roman numeral, which helps us eliminate the first choice, because we need to be able to distinguish between the 2 different states that iron can have. We never need a Roman numeral after the second element. Keep that in mind. If you ever see that, it is wrong. You can cross it off right away. So now we just need to figure out, well, which iron are we talking about? Iron 3 or iron 2? Well, there are 3 sulfurs. Those 3 sulfurs have a charge of -2 each, which means a total charge of -6. If the total negative charge is 6, the total positive charge has to be 6. And the total charge divided by the number of irons, 6 divided by 2 gives us 3, +3. So that iron has a charge of +3, which if you then go backwards, right, if you crisscross the numbers, you've got 3 and 2, you end up with Fe2S3, which is what we started with. So that tells you that the iron has a charge of +3, and we use a Roman numeral 3. Remember, key point here. The Roman numeral is the charge, not the number of atoms. Okay, so whatever the charge is, that's the number that should be in parentheses as a Roman numeral. All right, so now we have MnCl4. What is the correct name? All right. right, this is another one similar to the last one we did. We have chlorine, which has a charge of -1, always. Then we have Mn, which is manganese, transition element, can form multiple oxidation states. So we need to figure out, well, it's chlorine -1 times 4. So there's 4 of those. That means a total charge of -4, which means the total positive charge has to be +4. So we have manganese 4 chloride with the Roman numeral 4. A diagram of electromagnetic spectrum in order of decreasing frequency. So the left-hand side has the highest frequency, the right-hand side has the lowest frequency. Which of the following is true? So the first one, infrared waves have longer wavelengths than microwave. Infrared is here, microwave is here. Well, if they have lower frequency, they also have to have, because frequency and wavelength, if the frequency goes up, the wavelength goes down. If the frequency goes down, the wavelength goes up. So since the frequency is going down from left to right, that means the wavelength is going up. So that's not accurate. Ultraviolet waves have shorter wavelengths. Well, we just said that as the as the frequency goes down, the wavelength goes up. So that would mean that if the frequency goes up, the wavelength goes down going this way. Ultraviolet waves have a higher frequency and therefore shorter wavelengths than visible light. Which of the properties of waves is directly related to frequency? Well, we discussed in the last slide that wavelength and frequency are actually opposites. They're inversely related. The thing that's directly related to frequency is the energy. Higher frequency means higher energy means higher frequency, and vice versa. Lower energy and lower frequency go together. Okay, again, talking about the energy, ultraviolet light has high energy, which is why it's dangerous. It can damage our cells. So compare that to infrared light, which has higher energy than infrared light. Which of the following shows the visible colors? Well, keep in mind we're going from violet has high energy to red having low energy. Ultraviolet is beyond violet, infrared is below red. So we want to compare the colors in terms of which ones are closest to ultraviolet being the highest energy and red being the lowest. And then it says from lowest to highest. So red is the lowest, so we can cross off the first two. Now, which of these colors go in order from closest to red to closest to violet? That would be this choice: red, orange, green, and blue. That's in order of the rainbow, going from red at the lowest energy toward violet at the highest energy. Which of these has the highest wavelength or longest wavelength? Again, keep in mind, energy, we've already talked about ultraviolet having higher energy than infrared. So that means ultraviolet has a shorter wavelength because it's the wavelength and energy go in opposite directions. So which has the longest? Well, it'll be the one in the direction other than ultraviolet and past infrared, which is going to be radio. What is the relationship between wavelength and energy? So the relationship between wavelength and energy of electromagnetic waves. We've touched on this in a couple of the other slides. Wavelength and frequency are inversely related, which means they have head in opposite directions, and frequency and energy are directly related. So by association, if energy and frequency go together and wavelength and frequency are opposites, then that means that as the wavelength moves in one direction, the energy would go in the opposite direction. So as wavelength decreases, energy increases. Okay, a student puts water in a graduated cylinder and then adds a rock. What is the volume of the rock? So in order to take a look at this, what we really want to see is what is the volume of the water before and then after the rock is added. So it looks to me like before it's at 150 milliliters. And after, if this is, looks like each line represents 20 milliliters. So 20, 40, 60. 60 milliliter difference. Which is not one of the choices in this video, but it will be. It should be 60 milliliters. Okay, if you have sand and iron filings mixed together, so a mixture of sand and iron, which of the following pieces of equipment could be used to take them apart? Well, you want to think about what are the properties of sand and iron that you might take advantage of. Could you separate them with a funnel? Not necessarily, because if you put any kind of filter in there, the sand and the iron are both going to get stuck in the filter, and that doesn't really help you. You can't weigh them out from each other, and if you heat them up, neither one of them has a very low melting or boiling point, so that's not really going to help. The one that's going to help you separate them is a magnet, okay, because iron is magnetic and sand is not. So if you put a magnet through the mixture, the iron filings will stick to the magnet and the sand won't, and then when you take the magnet out, you'd have the iron filings separated by the magnet. Last one. Here's a ruler. What is the correct length, or in other words, how would you record this measurement correctly? You have to remember that we're talking about what's called significant figures, and your answer, when you take a measurement, should always be 1 decimal place more precise than the instrument that you're using to measure with. So in this case, we can see that the ruler has measurements or increments or markings at every 10th of a centimeter, which would be a millimeter. All right, so this line would be 1.1. This line would be 1.2. And the measurement is in between 1.2 and 1.3. So you want to estimate 1 decimal place beyond what the ruler says. So in that case, I would say 1.25. Okay, 1.2 is not precise enough because you know it's 1.2. You always want to estimate 1 extra digit. 1 is not precise enough. 1.256 is too precise because you're guessing that it's the 5, the hundredths place. So adding a thousandths place is just making up and adding error to your situation. So those are the questions that will be on the second half of the mid-year exam.